Okay, so we are on page 99 in the book, and this is section 1.12. And so go ahead and pause it and read question 1 here and try to answer questions A, B, and C on your own. I will give you a hint, like on A, it asks for a percent. So again, think about what math you do when someone asks you to find a percent. So I'll be back in just a second. Okay, so let's see what you came up with here. So it says what percent. So right away, you know you're going to divide and then get an answer and multiply by 100 because that's how we get percents. And not only do you divide, your units have to match. So it says what percent did the ticket price increase? Okay, so, and it might be deceiving here, but this is 2015 here. So from 2014 to 2015, it went up what? $3. And we're going to divide by the original. So you always divide by where it started at because you're trying to say the percent of where it's going to go next. So you look at the change and then you always divide by where it was, the start, and then that's going to kind of predict where it went in the future. So if you divide these, multiply by 100, you're going to get approximately 3%. Okay. And we call that percent increase or percent decrease when you look at the change of how it changed and divide by the beginning or the start and then multiply by 100. That'll give you that. Okay, it says B, use your answer from part A to focus. Okay, so now we're going to use a percent. So when you use a percent, you always multiply. So we're going to take 3% in decimal form and we're going to multiply it by the $99. And we're going to predict where we think it's going to be. And so that's going to give us kind of how we think it's going to change by. All right, so it's going to change by about $3. And so it's going to increase by about $3. So if we take the price of what, $99 and add that $3 to it, we're looking at about $102. Now, instead of finding 3% and then getting the answer and then adding it, a faster way is to use a multiplier and to say, well, I'm keeping all of the old price, but then I'm going to add 3% to it. So all of it is 100%. I'm going to increase it by 3%. So I'm really wanting to find 103% because this is 100% plus the 3% because it's growing. So I really want 103% of the old price to predict a new price. And what that does is that kind of combines it all together. So it kind of does this and the adding, but it does it in one swoop because this is 103%. And so if you do that math, you're still going to get the same answer of 102. Okay. And then it says between 2000 and 2015, what percent? So again, I know I'm going to divide. Did it increase? So it wants to look at percent increase or decrease, which is always the change divided by the start or the original price. Okay, so from 2000, so let's kind of erase some of the stuff here. In 2000, that's at the start, that's at $40 right there if you see the dot. And we're going all the way to 2015. So pause the computer, see if you can find the percent increase or decrease. Okay, so I'm looking at what percent did it increase. So from $40 to $99, the change is what, about, or exactly $59. And then you always divide by the beginning or the start. And so if you divide and you don't multiply by 100, you might think, oh, you know, it's like 1 point, but remember, you're not done. After you divide, you multiply by 100 because this is actually more than 100%. 40 out of 40 would be 100%. This is more than 40, so you're above 100%. So your units will cancel when you divide, but then you still have to convert it to a percent. So when you multiply by 100, you're going to get about 130% for your answer. So again, so after you divide and multiply by 100, it's over 100%. All right, let's pause, and then why don't you go ahead and read through that next example, and we'll pick up on the next page. Okay, so hopefully you read all of this. If you're not, you might want to pause and try again. And again, they talk about a multiplier. They give you an example of doing it in 2 steps and 1. And so read that. And then what I want you to do is at the bottom of the page here, I want you to try to find the multiplier for if I want to increase by 22% in one swoop instead of doing 2, like 0.22, getting that answer and adding it to the original, and decrease. So think about what the multiplier was, and that means you do it in 1 step. So try that, reread if you didn't, and try both of these. Okay, so if I want to do an increase of 22%, I could take whatever my amount is. I could multiply by 0.22 because, again, you always multiply to use a percent. I could get that answer, and then I could add it to the original amount. But that's 2 steps. And so we kind of want to get away from that. So instead, we can use a multiplier. So with a multiplier, you either take 100% and add or subtract whatever your increase or your decrease is, and then you put it in decimal form. So if I'm increasing by 22%, I have all of it, plus I'm actually gaining 22%. So that's 122%, which in decimal form, so 122%, if I move the decimal back, this is what my multiplier would be. And it would basically do the same thing as getting 22%, finding the answer and adding it and getting the new answer. If I multiply the original amount by that, it's going to do all that math for me. Same thing with the decrease, except I'm losing. So I have 100% and I'm losing 22%. So instead of doing 22%, getting an answer, and then taking the original amount minus that answer to get the new amount, here I can just do the math with my percent, which is, what is that, 78%. But again, I got to put it in decimal form, so 0.78. All right, read the next example, and then we'll pick up on the next area. So the top of page 101. Okay, hopefully you read through the salary example on page, let's see, the bottom of page 101, 102, 103, and the top of, there's an example on 104. And then there's more on the bottom of page 104 and the top of 105. I am going to come back to Excel, and we're actually going to talk about the salary thing together in another video. So just kind of skip over that for now. Hopefully you read through it, but you can skip over it and start on page 105 for now. All right, so again, let's talk about what things mean here. So go ahead and try to find the multiplier, and then, or sorry, interpret the multiplier. So they're giving you the multiplier, so I want you to go back and give me the percent change. So try that, and then I will come back and we'll go through these. Okay, so let's think about these. So remember, if it's like a, I don't know, 15% increase, then that means your multiplier would be, you'd have 100% plus you're adding 15%, which is 115%, but that's as a multiplier 1.15. So if it's above 100%, you're going to have a multiplier above 1. What happens if it's a 15% decrease? Then you'd have 100%, subtract the 15%, which would end up being 85%, which notice that's less than 100, and in decimal form that would be what, 0.85. So when you're losing, your multiplier is going to be less than 1. When it's growing, it's going to be more than 1. All right, so let's look at this one. So this one, if I make it into a percent, if I multiply by 100, would be 137%. So it's definitely growing. So it's 100% plus 37%. So that must be a 37% increase. But the next one, notice this, if I multiply by 100, is 51%. So I'm only keeping 51% of the value. So this is 100% minus some number is giving me 51%. So how much am I losing? So if you subtract, you're like, oh, that would be 49. So this is a 49% decrease. So I can't just look at the number and tell like I can with increase. I can look and be like, oh, it went up by 37%. Here I have to think of what did I lose? And that's my decrease, 49%. All right, so fill in the chart here and then try to figure out how many of these down here are correct and which ones are correct. And there are more than one. So try to figure out how many of these are true, fill out the chart, and then I'll come back in a second. All right, so let's see. Hopefully, I'm going to try to maybe do red here. Okay, so let's see. The husband started and lost some weight, so it looks like he lost 14 pounds. And the wife, she also lost some weight. If I subtract, she's lost 10 pounds. Now, percent of weight loss or whatever, increase, decrease here. You always take the change divided by the original or the starting amount. So he lost 14 pounds. I want a percent, so I know I'm going to divide, but I have to divide by his start. And again, notice units match, pounds and pounds. So those are going to cancel. Again, multiply by 100. And so his was 3.7%. All right, now let's look at hers. You always take the change divided by the start or the beginning, because we want to predict where it went, where it's going or where it went to. So it doesn't make sense to use the ending value because that's where you're landing on. The percent is telling you how you're getting there. So 10 divided by 200, and again, your units match, pounds and pounds, but they cancel. And again, multiply by 100 to move the decimal. So that ends up being 5%. All right. So double check your chart. And again, I'm going to pause again, try to figure out which ones of these are correct and not. There are 3 that are correct. So which 3 of those are true? All right. So let's look at these here. So did the husband lose more pounds? So if we're just comparing pounds, did the husband lose more pounds? And that is true. So that's a good choice. The wife lost a higher percentage. Okay, so let's compare percent. And she lost more of her body weight than the husband. She lost a higher percent. That is true. All right. Now, C and D, let's look at these because these get a little tricky. Okay, the wife's new weight is 95% of what she was originally. Okay, so again, to use a percent, you always multiply and do what it says. So put the percent in decimal form. And then of means multiply what her weight was originally. So let's go look at that. It was 200. So if you multiply 95% times her original weight, which is what it tells you to do, hit enter on your calculator, do you get her new weight? All right, and the answer is yes. So those 3 are actually correct. All right, now let's look at the last one, and this one gets a little tricky here. So, the wife's weight was 5% more than her ending weight. And yes, she lost 5%. So some people are like, well, can I just add that back in? And percents don't work that way because they're moving targets. So let's look at it at the beginning. The wife's starting weight was 5% more than her ending weight. Okay, so let's take her ending weight, 190. And then if I can either add 5%, so I can figure out what 5% is, get an answer. All right, so 10% would be 19. What's half of 19? Is that 9.5 pounds? And I can add it back in to the 190, and I get 199.5, which is not exactly 200. The other thing is it's faster to use a multiplier. So instead of doing that, I could just do a multiplier. Excuse me. Sorry, got a nice little cold coming on here. So I can take my 190. And if I want 5% more, I can do 105%, okay, because that's 100% plus my 5% in decimal form. And again, I do not get back. It doesn't equal that 200 pounds. It doesn't go backwards. And that's because when you do the math forwards, you're doing the math on the 200, but now you're trying to do backwards and you're doing the math on the 190. And so pause and think about that. Okay, so really quick, I want to talk about why that doesn't undo. So say that you, I don't know, make $500 at your job, and your boss is like, well, you're going to make 10% less. So you could find 10% and subtract it, or you could use a multiplier of 0.9, because 100% minus 10%, and you're going to get, what, 450? Okay, but now notice if you go backwards and you try to add that 10% in, that would be 100% plus 10%. But you're doing it on a new number. You're not doing it on the same. And so if you do the math, you're not going to get back to the 500. Okay, you're going to get back to what, 495. So you're going to get close, but that number is not the same. And the reason is here you're doing the math on 500 to get the new amount, but when you give the 10% back, you're doing it on the new amount, And so you're not going to get back. So percents don't undo that way because